how to write formula. So this is one of these key skills that you should know, and anytime you are writing an equation, you need to check that you're doing this. Okay, we see lots of beautifully balanced equations where people have got the formula completely wrong, and therefore it means nothing. Okay, so first thing to do is the ones that tend to tip people up are the ionic ones. Okay, remember that what the formula is showing you is the ratio of cations to anions. And in an overall ionic molecule, you've got to have it neutral. Okay? So if you've got something like aluminium oxide, each aluminium ion has got a charge of 3+ on it. How do I know that? Well, I know that it is in group 13, which means that it's got 3 outer shell electrons. And I know that being a metal, it's going to give up those outer shell electrons to become positively charged. So it's going to get 3+. Oxygen, I know, is -2. I know that because it's in group 16. So it's got to gain 2 electrons to get a full outer shell, because it's got 6 in the outer shell. And being a non-metal, I know that it is going to gain. So it's going to get a negative charge. A couple of ways of making these formulas. I could say, well, if I multiply 3 by 2, then I'm going to get 6, which means my overall total charge that I've got to balance is 6. To get to that 6, I need 3 aluminiums, so I'll have Al. To get to that overall charge, I need 2 aluminiums, so I'll have Al2. To get to that overall charge from oxygen, I need 3 of them, so I'll have O3. The slightly cheatest way is to take this 3 and this 2 and cross them over, by which I mean the charge on the oxygen is 2, so I'm going to cross that over and make that the number of aluminium atoms. And the charge on the aluminium is 3, I'm going to cross that over and make that the number of oxide ions. So our general rules: cation goes first, anion second. Positive and negative ions have to be combined so that the overall charge is equal to 0. The number of ions has to be put in subscript, and it has to go after. And if you've got a polyatomic ion, you've got to put the ion in brackets and the number of those ions after the brackets. So this is what we mean by polyatomic ions. Poly, many, atomic, atoms. So they've got more than one atom in them. So something like sulfate is polyatomic. Hydrogen sulfate is also polyatomic. Okay? For unit 1 and 2 chemistry, this table is going to appear in your data book. For unit 3-4, it's not. So you've got to know these polyatomics, or the common ones anyway. Most of these metals you'll be able to work out from the periodic table. Things like copper 1 or copper 2, well, that number in Roman numerals in brackets, that tells you its charge. So, for example, something like silver sulfate. Now here we've got a polyatomic ion. Okay, we need 2 silvers to balance the charge on the sulfate. So it's Ag2SO4. Even though sulfate is polyatomic, I'm not putting it in brackets, because I only put it in brackets if I need more than one of it. Calcium phosphate. Calcium's got a 2+ charge, phosphate's got a 3 neg. So the lowest number that they both have are factors of is 6. So we're going to say we need 3 calciums and 2 phosphates. 3 calciums and 2 phosphates to get that total charge of 6. So Ca3, and here I have had to use the brackets because I need more than one of them. So PO4, close brackets 2, which tells me I've got double of everything in those brackets.